All right, in this question, we're trying to determine K when we know our delta G naught, or delta G at standard conditions. And so what we learned in class was this related through an equation, delta G equals negative RT natural log of K. Now, a couple things to be aware of. Temperature has to be in Kelvin. R is usually listed as 8.314 joules per mole Kelvin. I like to think of it as 0.08314 kilojoules because you have to either convert from everything to joules or everything to kilojoules. And so I'm going to convert this to kilojoules. Negative, you can't forget the negative. That helps keep, so when delta G is positive, that means it favors the reactants. So K should be small. So we got to account for that. So 200 Kelvin times natural log of K equals 22.7 kilojoules per mole. So I'm going to multiply my negative 0.008314 times 200, and I get negative 1.6628 kilojoules per mole. So I'm going to divide that out from both sides. So I have 22.7 divided by negative 22.7. Don't forget the negative. And I get natural log of K is equal to negative 13.65. So I've separated out that natural log of K. Now, put an E on both sides. That makes it K is equal to E to the negative 13.65. On the calculator, that's often the inverse of the natural log button. So I'm going to hit second natural log, which makes it E, and then negative 13.65. And I get K equals 1.18 times 10 to the negative 6. Does this make sense? Yes, we have a delta G that is high in my example, and it's positive. Positive means it favors the reactants, which means we should have a K that's less than 1. So we should have a negative exponent K, and we do with this 1.18 times 10 to the minus 6. There we go.